Today I'm going to explain the fourth lab assignment that is about developing two placement algorithms, most value best fit solver and most value worst fit solver. Also completing two healing operators for the genetic algorithm that I have already developed for you. Now let's go to the code. First, please go to the website and download the required files. I have already done that. And let me open this with Visual Code so that we can have a look into these codes. So here are the main files. The main placement solver to provide the solving services, test placement solver to send JSON requests to the main solver and ask the solver to solve a specific problem for it, and the EI placement algorithms where I implemented all analytical solutions and classes. We also have two EJS web pages to show results for these algorithms. So let me run the program first and show you how these codes come together. So here's the main page, placement solver, and I have 4 individual pages for each of these algorithms. And as you can see, none of them have received any problem, so they have not solved anything yet. So let me run this test. Now they have solved something. The worst fit haven't solved anything. The first fit, this is the solution. Following the first fit procedure, and this is the solution found by the GA. And this is the final solution. So I can see the solution value is 1291, and for the first fit is 1315, and for the other two there is no solution because you are supposed to write the code for that. So now let's go to the code. Let me start from the AI placement algorithm where the codes for the solvers are written. And here I have organized them through classes so they can be better understood and better developed. So I have a class for Kubernetes host with some properties. I have a class for Kubernetes jobs with some properties. I have a class for placement solution, which is basically a solution vector, which is a placement array. I have a placement algorithm, this is the base class for the placement algorithm, which accepts array of Kubernetes hosts, array of Kubernetes jobs. You can also import it from a JSON setting, and it would check constraint to see if a placement array is actually violating any constraint or not. And in this specific case, the constraint is the total amount of requested jobs allocated to a host is less or equal to the capacity of the host. and it provides a full report when it does the constraint check to say which host is violating the constraint. And for example, here it says total CPU usage, total memory usage, total networking usage, and here is the total capacity and the total free capacity. And then we have the calculated placement value, which is receiver placement array, and it sums up the job value for that placement. And then we also calculate the host utilization, and this is what you've been seeing here. So this is a report comes from this class. It's a host utilization. And then here are several classes that extend this placement algorithm. So one of them is most valuable first fit solver, which is this one, first fit solver, and then this is the solution it found. And here is the constructor, is a super, so we call the base class, the placement solution, placement host utilization, and here is how you're actually going to solve it. So you need to read this code, understand how it works, and then get inspired by it and write the other two classes. I have the most valuable best fit solver, and this is where you're going to write the solver, implement the most valuable best fit algorithm here. I have the worst fit. I have here you're going to implement it for yourself as well. I have the genetic algorithm, which is very complicated, so I have implemented the whole GA and only left to write 2 healing procedures for it. So here is the GA, and as you can see, we receive several parameters like the current population, next population, the roulette wheel, and the function to heal chromosomes. And this function is not, but it's a function pointer, so you can point to a function that you want to call. The final answer and the array of solution history, which is basically saves the best, the worst, and the average value for each population. And this is what we're going to show here. So this is the best, the worst, and the average, and also the CPU utilization that is calculated by the main. So we have we also have a termination criteria, which basically says when we're going to stop the GA, because we can always produce next population and we can go this forever. So in this specific case, we're going to count the number of iterations that we haven't made any improvement, and based on that we're going to terminate. And then here is a function to generate the random population. So this is population 0, or initial population they call it, and I randomly fill a host with jobs. Here is how I generate the roulette wheel. Here is how I get a random chromosome from the roulette wheel, and here is where I log my best solution, and this is to show here. And here is the operation elitism, which I would copy specific percentage of my population, my current population, to the next one, and for that I'm going to sort them first so that I would know who are the best chromosomes. Here is where I do the crossover operation, here where I do the mutation operation, and here I do the, and here where I'm going to heal my chromosome. So here's operation heal chromosome trim. This is a trim procedure that I have explained to you before. This is the operation trim fill, where you're going to write for yourself. This is the operation trim smart trim fill, which is you're going to write for yourself as well. And here is the solving procedure, where as you can see it takes one of these healing of it first takes one of these healing methods, trim field, smart trim field or none, and it would set the function pointer to that specific function. And then I'm going to generate the random population, and then I'm going to do the loop of basically producing next generation from the current one. And I'm going to do the elitism, and I'm going to do the roulette wheel, and then I'm going to do the crossover and the mutation. And then after crossover and mutation, I'm going to heal my chromosomes according to that function that I have picked. And this is how I'm going to export this solver so that I can use them in my main placement solver. So if I go to the main placement solver, just like before, I have the express IP path, and I'm also going to import some placement algorithms from this function, and I can only import those that I have exported here, these 4 specifically. I'm going to make an instance for each of them, and then I'm going to do the typical thing, waiting for slash, and then if it's a slash, I'm going to say I'm going to show this page. If I receive a slash GA, I'm going to show the answer that I found by the GA solver, and this is where I'm going to do it for the first fit, for the best fit, and for the worst fit. So all is already written for you, you don't have to do anything about it. And then I listen to slash JSON, and this is where I'm going to get my commands from this test placement, large, small, or medium. And this is how I'm going to interpret the command that I receive. So I receive message type as config or update, or message type as command, which basically runs each of these algorithms. And here is the run for these simple algorithms, like most fit, is actually one call, but the run for the genetic algorithm is a little bit more complicated because the GA may take some time to convert to a solution, and therefore I'm going to clock 50 generations, and using that 50 generations I'm going to basically update the results on the screen during the GA operations. And then here's where I delete all the data, and this is where I would fetch my solution, because as you can imagine, if this solver is somewhere in the cloud or in the edge or wherever in the platform, then you actually want to get the solution found by the solver, and this is the solution that it has found. For example, it said how jobs should be placed, the placement array and the placement value, and this is how you would return. And obviously I'm going to listen to a specific port for that. So let me explain this test placement, large, say for example in this case. So again, I use the Axio to send Axio posts, and then I have this URL for my solver. In this case, this is the URL for my solver. And then I'm going to a message type setting, which I'm going to say what algorithms do I have, what parameters do I have. For example, genetic algorithm, population size 100, and the optimization parameters. For example, elitism, percentage, or crossover, or blah blah blah. And then healing method, trim field, smart trim field, and the overpopulation factor, which basically means if I'm going to go from one generation to another generation, instead of producing 100 chromosomes from 100, I would actually produce 150 from 100, and I pick the best 100. And then I have the termination policy that says maximum total number of iterations 1000, or maximum number of unchanged best answer 100, which means if in 100 generations I could not improve my best answer, then I assume my GA is already converged. And here's the definition of the host. So I have, for example, I have 8 hosts here, and here's the definition of my job. So I have job 1, job 2, and these are the these are the characteristics of each job. So let me, and then this is where I'm going to send my command to the solver. I said delete all data, and then start the most valuable first fit, and then start the most valuable best fit, and then start this worst fit, and then eventually start the GA. So let me run that one more time so that you would see how it would work. So here is the solver I have, and if I say, for example, if I write a smaller one, those placement, say large, for example, sorry, the large one. Here you would see they would be updating themselves every few seconds anyway. The worst fit, no solution. The best fit, no solution, because you're supposed to write them. The first fit, the 8 hosts, and this is how the 8 hosts are actually filled. And this is the solution value, 4,262, and this is the GA, and as you can see, the GA is improving, and the web page is showing the progress. And here is the best chromosome that it found, over 149 generations, and this is the average, and this is the worst. Still improving. But you can see the first fit has already finished, and this is 4,200. So the GA hasn't reached that yet, which means the solution found by the first fit is still better. So while it's still working on the solution, let me show you, go to the code again. So this is where you're going to write your algorithms. So as you can see, the worst fit, it doesn't produce any solution, and therefore you have to write the solver here. And also the best fit, also it doesn't produce anything, whereas the first fit is actually implementing a solution. And this you can inspire by the way I have written this code, so that you can actually write the best fit and the worst fit for yourself. And also, if you go to the test algorithm, for example, here, as you can see, I have the healing method trim, non-trim, trim fill, and smart trim fill, and I have implemented only one of them, and the other two you're supposed to implement for yourself as well. And here is the other two that you need to write. So trim fill and smart trim fill, you're supposed to write these codes for yourself, so that when this option is selected here, trim fill or smart trim fill, you will be able to heal your chromosomes accordingly. So let me go back to the web page again, and as you can see, I have already passed that first fit, and it is still working. In this specific case, I'm using the trim method. And here is the final answer that GA found, so it marked as final. And this is because in the last 100 iterations, it could not improve, or it had reached 1,000 generation. In this case, it had reached 1,000 iterations.